In this session from the Street Identity Conference, we're going to talk about mobile strong authentication and get down into some nitty-gritty details. So we assume before you've watched this session, you've gone over the slides or presentations from a bunch of other things. Learned about OpenID Connect, learned about the account user, you're familiar with the OAuth part of OpenID Connect. And then from the Street Identity event, you understand the economics of attribute providers and have watched the session about the API flows for attribute providers. That you also understand the concept of a relationship manager and have some idea of the security differences of passwords versus one-time codes versus certificates, device IDs, and that you've watched the session on LMNOP. So assuming you've all done that background reading, keep on going. And if you want to, as you're going along, there are some documentations you can read that relate to this. If you go to streetidentity.com and go to the working group, there's specifically a user flows document for LMNOP that has a lot of content that we're going to discuss here. There's also a mailing list you can join. So the end goal is that a user should be able to go to a website that they've probably never visited before, that already the business has information about them, but that to get that information they need to prove who they are, prove their real-world identity, and the website may feel that they need to be strongly authenticated with more than just a password because of the sensitivity of the information, such as logging in to access your healthcare records. So in other sessions, we've talked about what might happen after a user hit the sign-in button with the account chooser, with attribute providers to share their street address, with a lot of the technology under the hood. One of the pieces we didn't explain in detail is how could this website learn that the user was in fact strongly authenticated, and what are the economics that might support it being able to get that information. In particular, in this session, we're going to talk about one particular scheme where a user's mobile phone, and in particular the certificate or SIM cards on that device, are used to strongly authenticate them. So imagine for a moment a user, Bonnie, she has decided she wants to upgrade to a new mobile phone. She goes to her carrier, Mobile X, picks her new phone, goes through the ordering process, but somewhere near the end she sees a promotion that, hey, if she'll just link her Mobile X account to her Google account, she'll get a much better experience. When she turns on her phone, it'll immediately know who she is, and Mobile X will help associate a verified street address with her account, help her recover her account if there's problems, etc. Assuming she clicks the promotion, she might see a page like this one, where Google is just confirming that Mobile X should have the ability to have some basic information about her, like her email address, should be able to act as her attribute provider for street address, assuming Mobile X has a verified street address, and that Mobile X can help the user log into new devices. Now, if the user goes through that flow, one thing that her relationship manager, in this example Google, would do is confirm that there's also some other factor that can be used to authenticate her. Maybe that's a password, but to improve usability, it might be that the relationship manager would ask her to associate a PIN with her account. In particular, the type of PIN that could be typed on a mobile phone for a common unlocking mechanism. Now, behind the scenes, if the user gives consent, what has happened is that Mobile X has done a traditional OAuth 2 dance with the user's relationship manager, in this case Google, and Mobile X did the OpenID part to get an email address for the user just to make sure it matches the account and the user didn't accidentally use the wrong account. Then, using all the techniques from the street identity attribute provider mechanism, it could associate a verified street address with their account. And then there's one last OAuth scope, which is for that login help. We'll come to that in a moment. But the end result, Mobile X should end up with a long-lived OAuth token that would be stored in the carrier's customer database for that account. Now, later, Bonnie would actually get her new phone. Maybe she bought it in the store, maybe it would get mailed to her. She would get it for the first time, she would turn it on. Now, most people are used to the fact that when they turn on the phone somehow magically already knows what phone number is associated with it. And that magic does involve a scheme where the device authenticates itself to the carrier then looks up what account and what phone number that device is associated with. That would still happen, but in addition, Bonnie would, after the phone was turned on, see the traditional unlocking screen, she would type that PIN that she had selected, or maybe the PIN she'd used on previous phones, and to the end user, she'd just immediately see an indication that her mail and address book, etc., are being synced. And voila, and the icon for her husband shows up. She clicks it. She's happy. She walks out the store. No more customer support costs. And there are multiple ways this experience might happen. Maybe there's a one-time process where she has to launch an app that asks for the PIN or even download that app. But at the end, the user didn't even have to type their password, but the phone is associated with her carrier account, with her phone number, and with her account at the relationship manager, in this case, Google, and all the services tied with her account at that relationship manager. Now, behind the scenes, there's a lot going on here. The first step is that the phone turns on and uses the carrier and device-specific mechanism to authenticate the device to the carrier and to be mapped to a specific user's account. Now, what happens next is some software on the phone will need to make an API call to the carrier's network to say, hey, I'd like some help getting this user logged in. And that API call needs to be bootstrapped by whatever's mechanism was used in the previous step to bind the device to the carrier. Now, the MobileX servers, when they receive that API call, should go and find the long-lived OAuth token that it saved in the customer record in the central account database for that user after the user previously gave consent. Once it finds that, it just makes a traditional OAuth 2 API call to Google and makes an API request to Google saying, please give me a login helper token. That token comes back to the carrier servers. The carrier servers in turn send it as the response to the API call back to the phone. Now, not done at this point. Now, next what happens is that the software would ask the user to unlock the device by typing the PIN or something else. The software then take the combination of both the login help token and the PIN and would send the combination of the two to the relationship manager, in this case Google. When Google received that information, it would confirm that the two are valid and are associated with the same account. And if so, it would return what we call a full access token, or sometimes we call it a God level token, to the phone. And within that token is just a little bit of metadata that we're going to talk about later that indicates that it was bootstrapped using the MobileX carrier and the device certificate. Now, in addition, behind the scenes, Google would send a notification to the user's account about the fact that a new device has been added. And we'll get to that in a moment. But this token has got what we call a God level token is now ended up on the phone. Once the phone stores that, it is basically itself a long-lived OAuth 2 token that can be used to go back to the relationship manager, Google, and ask for tokens for specific services like syncing mail, calendar, address book, etc. So it can use that to immediately make those things happen, which is why the user can see their data without ever having typed a password. Now, I mentioned that one thing that Google does is send a notification message, because while this is certainly an improvement in security for the user, there's no password to be phished in this case. There's still some circumstances under which there might have been abuse. So, Google would send a notification to the user, and the notification can be sent multiple ways. Maybe it'll pop up on all the computers where the user has an account. Maybe it'll be sent via email, postal mail, etc. But it might be a message like this one saying, hey, a new device from MobileX, it's a Android device, iPhone device, whatever it is, the model number, the phone number. It would tell the user this new device is associated with your account and give a link that the user could use if they wanted to go and say, no, that doesn't look right, please get rid of that one. But let's assume for a moment it really is Bonnie, so it's fine, she doesn't click that link. Now she has her phone, she has access to her address book, mail, calendar, that's all syncing, etc. But now let's talk about what happens when she launches the browser on the phone. The end user experience is she launches the browser and voila, she sees the Google homepage and she's logged in. In fact, those of you with more recent versions of Android will find that you already encountered that experience. As long as when you turn on the phone you associate it with your Google account, Google can help you get automatically logged into Google on your browser. Again, multiple ways this user experience could have worked. Maybe she had to use some special app to launch the browser and get automatically logged in. but still, user never had to type a password. So how did we do this? Well, behind the scenes, what we do is we go back to that full access or God level token that the phone has stored. And we use it to make another API call to Google, traditional OAuth 2, but this API call is to request a web login code. Gets that code, the app then launches the browser to a specific URL at Google, and as a URL parameter includes that login code. The Google servers that receive that HTTP request with that URL parameter can validate that code, determine what account it's associated with, and as long as it's still a valid code, it would then issue a session cookie to the user's browser saying, great, you now have access to that account. Now, a very important thing to notice here is that that session cookie is going to contain metadata of how it was bootstrapped. In this case, the session cookie came from this one-time code that came from that God level access token that came from MobileX starting the whole flow using the device certificate. So we create sort of breadcrumbs and constantly keep the information about this particular session as having been bootstrapped using the device certificate. So that information is actually in the browser cookie now sitting in the user's browser. So now let's take the next step. Imagine that Bonnie then in her browser, she goes and visits some website that wants to strongly authenticate her or knows she's been strongly authenticated, goes to the site, clicks sign in. She's an account chooser, quite possibly, chooses your account that might be over at Google. When she gets there, assuming she had never visited the site before, she would need to then give consent for that site to have access to her verified street address or email, etc. After she gave that consent, now via an OpenID Connect, she would get logged into that website. And the end user experience is she's logged into a website and voila, she sees her recent lab test results, including ones that are potentially very privacy sensitive. So what happened behind the scenes to cause MedClinic to decide that she had been strongly authenticated, and therefore it was okay to let her into the account, and as well to know that it was in fact her associated with her medical records. So MedClinic just performed a standard OpenID Connect flow on top of the OAuth 2 protocol, and it had a couple of scopes requested, one to do the login with OpenID Connect, another to get access to her verified street addresses using the street identity and attribute provider mechanism, and the last scope was to get access to her session-specific authentication mechanism. Assuming this was her first visit to the site, the website would then go and get her verified street address, use that to find out if there are records for someone living at that address, and as a side effect, cause money to be paid to her attribute provider for street address. But then the next thing that MedClinic would do is it would make another API call to Google's what we call session auth mechanism endpoint. And it would actually include the same session token that was used during the login part of the OpenID Connect flow, which was discussed in other sessions. That token continues this breadcrumb idea that we talked about, where that token would have metadata in it that said that it came from another token that, way up at the top, had been bootstrapped using the device certificate. It would also, another thing to now point out, that breadcrumb would indicate who was the original authentication provider, which in this case was MobileX. So that information comes back to MedClinic, and at this point realize it's a claim to MedClinic that the user's authentication provider is MobileX, but it doesn't actually say how the user was authenticated. So what MedClinic can now do is turn around, take that token it got from Google, send it on to MobileX. MobileX would, just like the street address verification scheme, validate its proper token, and then MobileX would look in the token for some signed data from Google, where Google is asserting to MobileX, yes, in fact, this is a token that was bootstrapped using you. And now, at this point, MobileX could return an assertion back to MedClinic saying, yep, this user was strongly authenticated, or if not, return a false note. A very key thing to point out here, dollar signs, MobileX would probably charge MedClinic to get access to this information, maybe some per user per year fee for that information. Now, MobileX could return some relatively detailed information to MedClinic about, how it handles its certificate-based authentication, and the MedClinic website would then have to evaluate to decide, was it trustworthy, did it meet its requirements? Maybe MedClinic even has a complex system where it's dropping that into a risk engine, looking at things like time of day, user language, browser, historical information to decide whether to log this user in. But assuming all of that was passed, the user now finally achieved the goal of being logged in to the website with their sensitive information where it knows who she is, and it all happened to the end user with just a few clicks, and note the user never typed a password. Okay, take a big breath, pause if you need to, because we're going to go on and talk about some related issues that need to be pieced together to make all of this work, because there are some other scenarios. And we're going to start off with one, which is how does this work on a PC, because we only talked about it on a browser. So let's imagine the same user, Bonnie. She's got her phone, she's been able to use her phone to log into very sensitive websites, like that MedClinic. But she goes and maybe buys a new computer at a store. She turns it on, goes to google.com in her browser, or whoever her relationship manager is, clicks sign in. Maybe she's asked for just her email, or maybe an email address and password. But after submitting that information, she sees a screen possibly like this one. Shows her photo, shows her email address, but tells her, hey, we only partially know who you are. To confirm it, please do something else. In this case, that something else, suggest to her, hey, open the Google login application on your phone. Again, the phone is already bound to her account, and scan this barcode, located below. So that's something a lot of people would know how to do. Now realize there are multiple ways the user experience could happen here. Depending on the relationship between the phone and the relationship manager might be able to just push a message directly to the user's phone, and the phone could just pop up to the user, hey, there's a new device you're trying to authorize. Do you want to do so? Yes or no? And if you want to learn more about some of the security issues of those techniques, there's a great white paper by Ben Laurie called Choose the Red Pill and the Blue Pill. Or maybe the phone talked to the PC using wireless technology, Bluetooth, near-field communication, or direct signal like USB, etc. No matter what the scheme is, the user has to give this additional consent mechanism on the device. That then gets communicated back to Google servers, again in one of these different mechanisms, NFC, USB, that push notification channel to the phone, or just by the fact that the phone loads the URL and the barcode. The end result is that Google's servers will verify that, oh, okay, the user's done the other half of the authentication step and return a Google session cookie for that account. But again, I keep talking about this breadcrumb thing. That session cookie in the user's browser would include some metadata about how it was bootstrapped. In this case, that the very upstream source was the mobile phone, bootstrapped with Mobile X, and now it would include some metadata that device was now used to authenticate this second device, and it might describe the technique that was used, whether it's OCR, USB, etc. And so if the user on their PC, where they're now logged in, goes and visits one of these websites that wants to know how it's strongly authenticated, the website could get all of this information and use it to decide if it's sufficient to log the user in. So while that works, it does raise a bunch of questions, because we mentioned that there are quite a few different ways the user might get their PC logged into their account. And the security characteristics may vary depending on what technique was used. Websites might have a preference about what in a perfect world they would like the user to use, but it may well be that, for example, the person is using a PC that has no wireless capabilities and has no USB port, or maybe it's just a device where they can't figure out how to get all the software configured, and so they're left at the end of the day with just maybe a push notification to their phone or scanning of the OCR. Now, this was talking about a new PC. Another question, but not a huge one, that's raised is, well, what happened to Bonnie's current PC? The PC where, for example, she used to order her mobile phone in the first place, because back before she ordered the mobile phone, there's a good chance she had just logged in that phone purely with a password. So do we call that PC, strongly authenticated? Well, it's sort of the one that bootstrapped the whole darn thing, but does the relationship manager force the user to get logged out of that device and re-authenticate? A couple different questions there, but there are multiple approaches that could be used. Now, another thing to note is that if the user is authenticated on this new PC or even their existing PCs, and they get authenticated, there are two more things that are likely to happen. The first is that Bonnie would be asked to name this machine, and the second is that a notification of this new machine would be sent out to her other accounts. Again, just in case there's something fraudulent, going on. This also has the advantage the user could go into their relationship manager, see a list of authorized devices, and just revoke individual ones. Okay, another breakpoint. We've talked about a user with a new PC, additional PCs. What about if someone needs to replace their phone? How's that going to work? Well, for the end user, pretty easy. The user loses their phone, breaks it, whatever. The user goes into a store, says what the problem is they're having, or maybe just takes in a phone that's working unstably and the mobile carrier determines it's a hardware issue. Now, here she does something interesting. She shows her state-issued driver's license, as a form of authentication, and she gets her new phone. Great, turns it on, and just like with her first phone, it comes on, it shows her name, but asks her to unlock it, types her code, all the magic happens with the different tokens, and she sees her data. Now, something else that she might notice is that very soon her other phone would beep and indicate it no longer has access to her account. So how did that happen? Well, behind the scenes, that same token bootstrapping process happens, but there's one step we left out. When MobileX took its long-lived OAuth token, stored in the customer account database, it made an API call to Google's Login Help API and asked for a token to bootstrap the phone. Another thing it did was it passed over the phone number of the target device. Now, if the user then activates that device by also typing their code, that information gets back to Google or the user relationship manager, who can detect, oh wait, this is a second device for the same phone number. So Google can just automatically disable the token associated with the first device bound to that phone number. You'll also notice that that phone number is used in the notification message sent to the user's account about the new device. So that's a very nice security characteristic. Of course, that is for replacing a phone. The user might choose to buy an additional phone, or maybe buy a tablet with a 3G, 4G connection from the carrier. In this case, there is a unique phone number associated with that device, so a different phone number gets sent to Google. So Google wouldn't turn off her old device, but again, a notification of the new device would be sent to the user's account, including, generally speaking, information that could be collected from the carrier or from the software on the device about the operating system, hardware of the device, other things that might give the user hints about what device it is. All right, we're getting closer to done here. But now, one of the key things we have discussed is we've talked about more strongly authenticating the user, but we need to go and check that and consider a lot of the different possible attack vectors. Are they mitigated, are they not? Are we leaving big holes in the background, for example? So, one of the most basic ones is, hey, a hacker who knows the user's password, could they break into her account? Well, let's see. She's got her account in this state. Then, and if the hacker, maybe knows Bonnie's email or password, because maybe, especially if a password associated with account she might have reused on a lot of other sites, well, then the hacker could bring up his browser, go to the login page, type the email address and password. But at this point, the hacker will now see this note saying, okay, well, you're only half logged in. You need to now scan the barcode with the phone, or do the USB, NFC, etc. Option. There, of course, is the potential for the hacker to, trick Bonnie into authorizing the PC through some, social scheme or other technique, or maybe if a wireless protocol is used, there might be some form of, man-in-the-middle attack. So, nothing in security is ever always perfect, but it certainly drastically raises the bar over phishing for just a password, or even phishing for a password plus an OTP, which is still not too difficult form of phishing. And of course, even if a hacker, does socially trick her into doing this, there's still this notification that goes to her account, so she could disable it from other computers either now or in the future. But again, we've raised the bar quite dramatically here for the hacker. Certainly, way beyond what a hacker has to do with the password a person reuses across websites, but also significantly above the bar for an account protected with a password plus one-time codes. Now, another potential attack vector is, what if there's an evil employee who works at MobileX? They could just pretend that the person came into the store and showed their photo ID, and the MobileX employee could give themselves their new phone associated with the user's account number. But if they did that, when they turned on the phone, it would say, "Hi, Bonnie," but would now ask for her PIN. And if after a few attempts, it wasn't successful, well, that token could be invalidated. Or even more broadly, if Google sees a whole bunch of tokens get invalidated from MobileX, it could just completely lock out MobileX's access to her account and perform some account recovery with the user. Well, unfortunately, that might even involve something as low-tech as sending a one-time code via postal mail to the street address that MobileX gave user to Google for street identity. So that's one scheme. Another scheme is, hey, the evil person isn't an employee of MobileX, just some evil person that creates a fake photo ID for Bonnie, walks in the store and shows it, tries to get a phone. Again, it has the same protections in place. Or maybe it's still an evil MobileX employee, not in the store, but in the data center, who actually has access to the long-lived OAuth token. Again, that's fine, still has the PIN problem, because the OAuth token by itself, the one that's stored in the customer account database, doesn't give complete access to the account, or actually any access without the PIN. Of course, plenty of other attacks. One is just stealing the user's actual phone. At that point, you need still the unlocking code. Once you do, you get access to lots of information. And at that point, it doesn't really matter whether the phone was, the user set up the phone using just a password plus OPT, or the certificate on the phone. Once the user steals your phone, quickly they'll get access to a lot of information. But fortunately, users tend to notice if their phone is stolen or disappears. Of course, there are other social engineering tricks hackers might use, trying to convince the users to give them their PIN, or maybe they'll find that the person reused that PIN on other places that can be hacked, like an alarm code, ATM code, voicemail code, etc. But if any of those schemes are used to authorize a new device to get access to Bonnie's account, Bonnie will still get notified of the new access. And in fact, the risk engine that systems like Google deploy have a lot of details they look for when a new device is connected to account, and so it might use those signals to block access anyways. So hopefully you got through all of that. Again, very close to done. Just one last issue to discuss, which is what happens if the user wants to change their carrier but still keep their same relationship manager. Well, there are a couple of different options here. So the user is going to go through some sign-up flow, on a kiosk, or, on their PC, etc., with the new carrier. At some point in there, they're going to be asked to go through the same consent flow to bind their new mobile account to Google. And to do that with Google, they need to be on that browser logged into Google, strongly authenticated somehow. Well, if the user is doing it on the current PC, fine, they're already authenticated. If they did it on, say, a kiosk in the store, well, maybe they still have their own phone, old phones, and they could use it with NFC or scanning barcode or something to authorize that kiosk. The worst, scenario is the user no longer has access to their old, PC or phone, or at least no access to an active session, and so Google might have to perform account recovery in this case. Again, that might be as painful and low-tech as sending a one-time code via postal mail to their house. And then there's just one last topic I'm going to throw in here. You thought you were done, which is we've talked about all these scenarios of phones being issued and users giving consent. And that assumed consumer-oriented scenarios where it's a user making a decision for themselves. But if an enterprise bought the phone, issued the phone to an employee, and wants the phone to access the employee's corporate email, well, then the enterprise can make those consent decisions on the user's behalf. A good example here is traditional BlackBerry enterprise server deployment, where the IT department, they get a BlackBerry phone, they look at the back, find the device ID, go into some application to map that device to the corporate email account, and then when the user turns on their BlackBerry phone, boom, they see their data and the phone knows who they are. So you could do something similar here. The user doesn't have to give consent for MobileX to have access to a personal account. The IT admin can just globally tell Google or their corporate consent relationship manager that MobileX should have access to all or a subset of their employees' corporate accounts. It would have to provide this mapping information and the unlocking codes if it still wants them. But other than that, the experience is still the phone. Now it's still the same, the employee turns on the phone, types their unlocking code if they need to, boom, it knows who they are, they have access to their data, they can open their web browser, get logged in, visit websites that need to know they're strongly authenticated, and it will all work. In addition, when we talked before about all these notification messages that go to users about new devices, well, those can also be sent to the IT administrator who can monitor them and detect potential problems, disable devices, etc. And one of the advantages also here is under scenarios where a phone is lost or broken, the employee doesn't go into the store of the carrier; they go to the IT administrator who potentially can do a better job of authenticating the user. Great. That's it. Really, hope that we're done at this time. If you have, questions or want to raise some additional discussions, what we hope we will do is actually join the working group. Go to streetidentity.com. You can read information about the working group, and there's a mailing list there that we hope we will join. Thank you very much for your time.